Both fractions and decimals represent values that are part of a whole. We can change forms between fractions and decimals to represent the same value. Let's start with fractions that have denominators of 10, 100, and 1000. These are going to be equivalent to the decimal place values of tenths, hundredths, and thousands. Here we have a tenths grid, and we can see that we have 3 out of 10 pieces shaded. So in fraction form, we have 3 tenths. In decimal form, we know that we would need to go out to the tenths place, and we have 3 out of 10 places shaded. So again, in decimal form, we would also have 3 tenths. Over here, we have a hundredths grid. If we count how many squares are shaded, we would see that we have 15 out of 100 squares shaded. So in fraction form, we would have 15 hundredths. If we wanted to express that in decimal form, we know we would need to go out to the hundredths place, and then there are 15 squares shaded. So in decimal form, we would also have the decimal 15 hundredths. Now, we're not always going to want to create a grid in order to represent a fraction and a decimal. So here we have the fraction 256 thousandths. In word form, we would also have the decimal 256 thousandths. To express this in decimal form, I know from my denominator that I'm going to need to go out to the thousandths place. Tenths, hundredths, thousandths. And then my numerator tells me I'm going to have 256 pieces. So we're going to fill in the 256 in our place value, and that would give us a decimal equivalent of 256 thousandths. Not all fractions are going to have denominators of 10, 100, and 1000, but some can be made into equivalent fractions with those denominators. Here we have 1/2. We can change 1/2 into an equivalent fraction with a denominator of 10. On my tenths grid, when I shade in half of it, we can see that we've shaded in the fraction 5 tenths. So 1/2 is equivalent to 5 tenths, and then we can take 5 tenths and write the decimal form of it as 5 tenths. The same can happen with 1/4. I can't change 1/4 into a fraction out of 10, but I can change 1/4 into a fraction out of 100. When we shade 1/4 of our hundredths grid in, we can see that we've shaded in 25 parts out of 100. We can then take the fraction 25 hundredths and write it as the decimal equivalent 25 hundredths. Not all fractions can be made into these types of equivalent fractions. To always change a fraction to a decimal, though, we can come back to dividing. When we divide our fraction, we can divide the numerator by the denominator. So if I wanted to change 3/8 to a decimal, I could divide. 3 is my numerator, and 8 is my denominator, so I would do 3 divided by 8. Now 8 doesn't go into 3, so this is where my decimal comes in. I'm going to put 1 behind the 3 in my dividend and also 1 up in my quotient. Now I can add placeholder zeros behind the decimal. 8 is going to go into 30 3 times. 8 times 3 is 24. 30 minus 24 leaves me with 6. To keep dividing, I'm going to add another placeholder 0 and bring it down. 8 goes into 60 7 times because 7 times 8 is 56. 60 minus 56 is 4, and I can add another placeholder 0 and bring it down. 8 is going to go into 40 5 times because 8 times 5 is 40, so at this point I have no remainders. So in a decimal form, 3/8 is equivalent to 375 thousandths. This is what we call a terminating decimal. A terminating decimal occurs when we can divide out our entire fraction into a decimal with no remainders. Let's try to do the same thing with the fraction 1/3. To make 1/3 into a decimal, I'm going to divide numerator by denominator. So I'm going to divide 1 by 3. 3 doesn't go into 1, so I'm going to put my decimal in my dividend and up again in my quotient and fill in my placeholder 0. 3 goes into 10 3 times. 3 times 3 is 9, so when I do 10 minus 9, that gives me 1. So I'm going to bring down another placeholder 0. 3 goes into 10 again 3 times. 3 times 3 is 9, so again I have a remainder of 1. If we do it one more time, we're going to get caught in that same cycle. 3 goes into 10 3 times. 3 times 3 is 9. 10 minus 9 is 1. This is a cycle that we're never going to break, so this is what we call a repeating decimal. Our decimal is just going to go on as 3, 3, 3, 3, 3 forever. To show others that it's a repeating decimal, we're going to put a repeat bar over the 3 to show that no matter how far we go, it's just going to be a series of 3s. No matter what type of fraction you're working with, though, we can always come back to division, numerator divided by denominator, to make our equivalent decimal. Check out the other videos in our playlist, and don't forget to click on subscribe. Thanks for watching!